Good afternoon, students. Thank you for coming. Welcome to our exam session for Mathematics 6. That is BESP Mathematics 6 M80. The code is M8032. My name is Loide Shikongo, your tutor for this subject. When it comes to mathematics, I want you to really study hard, prepare well in advance before your examination. And please, you should always contact me, not when you are going to write, but especially when you are doing your assignments, because your assignment is mastery, or when your examination is built the same way with your examination. I'm not saying you should study your assignment, but most of the content that in the assignment, those are the parts that we also integrate in the examination. Let's look at the first unit of this module: function notations and linear programming. These are the topics that are under this, the subtopics under this unit. What are we going to do here? It's not too much. I'm just going to present some of the content of this unit. The first one is drawing linear graphs and shading regions. I find that this is a problem to most of you. Linear equations, or inequality graphs, they're just like a straight line graphs, but in this case we go an extra mile of drawing or shading the unwanted regions, and also finding either the minimum or the maximum one. The inequality graphs, they use relationship signs: greater than, less than or equal to, or greater than or equal to. And then when we are drawing our inequality graphs, those are the type of lines that we mostly have. We have dotted lines, and then dotted lines, they use those two, either less than or greater than. And then we have a solid line, and then they use these two inequality: less than or equal to, or greater than or equal to. You should know which one to use, and it depends on which inequality it was given. Okay, let's look at this example. It said drawing an inequality graph and shading the unwanted region. This is the example that you have there. For example, we have the three inequalities: x is greater than or equal to 3, y is greater than 2, x plus 1 is less than or equal to 8. Now, in some cases, when it comes to inequality graphs, we have three ways of asking this question. You might be asked to just, like the question, you are given the inequalities already, then you have to draw them and then shade the unwanted and answer some questions. Sometimes you're just given no inequality, you have to give your own inequalities from a certain problem, draw your graph, and then find answer the questions as well. Or sometimes you're already given the drawn inequality graph, and then you answer questions related to that. Now it said, now the first question says, show the points with integer coordinates that satisfy all the three inequalities. That is the question. Now, for you to answer this question, you cannot just answer that question out of the blue. We need to draw the graph, and this is our graph. When you are drawing the graph, we have to the inequalities, we change them to the equal sign. So then when you are naming your inequalities, or when you are naming your graphs, we always use the equal signs. We don't use the inequalities signs. We use the equal signs when you are naming your graphs in the graph paper, on your graph or in your inequality graph. Now you turn, when you are drawing, you only turn these inequalities into an equal sign. So the x becomes x less the greater than or equal to 3. It becomes x is equal to 3. You draw that graph, and then you shade the unwanted. If you are talking about x, if if you're talking about x greater than or equal to 3, which numbers are not needed? So then you can see that the equation said we want numbers, x represent numbers greater than or equal to 3. Numbers greater than or equal to 3 is like 4, 5, 6, and so on. So then the 2, the 0, the 1, and so on, this other number, they are unwanted. That's why the shaded part is this part. We shade this part for that. And then y greater than 2, you make it y is equal to 2. I hope you know how to draw this type of graphs. Y is equal to 2. You can see that inequality, it's a greater than, therefore we use a dotted line. Remember in our previous, this, if you are using these two, we have to use the dotted line. If you are using these two, you have to use the solid line. Okay, so for this, that is y is equal to 2, and which one are unwanted? The inequality said y is greater. I want numbers greater than 2. Which numbers are greater than 2? 3, 4, 5. Like these numbers up here, these are the numbers that are greater than 2. Otherwise, the numbers down, they are not greater than 2. So then they are not needed. We shade that part, unwanted region. X plus y is less than or equal to 8. We draw that. For this equation, x plus y, for you to draw this graph, we normally use the x-intercept and the y-intercept. We replace x is equal to 0 and we use y is equal to 0. If you want to know where your graph will cut the x-axis, where to cut the y-axis, so that you cannot go so much into what you don't need, you only use this. When x is equal to 0, you find the y-intercept. This one you get the y-intercept. When y is equal to 0, you find the x-intercept. So you substitute x in, you equalize x is equal to 0 here, then you find the value of y and see where your graph will cut the x-axis, or find where it will cut the y-axis. And then you shade the unwanted region. So you can see that we want numbers less than, x plus y should be less than or equal to 8. Which numbers are less than or equal to 8? These are the numbers. You can see the unwanted region is the one is up there, the unwanted region. So then from there, you will be able to answer your question now. Remember to shade the unwanted region. And then first, you can see that first show that x is greater than or equal to 3. Next, y is greater than 2, then show that. Now, show the points with integer coordinates that satisfy all the 3 inequalities on the diagram. Then we normally find, the question said, find the points with integer coordinates that satisfy the inequality. We put the integers, we draw points, we give the points in the unshaded region. Now, your points, when you are giving your points, that point should not be in the dotted line. It must not lie in the dotted. So like you cannot pick this point 6, 2. You cannot pick this point because this number here, it's in the unshaded, in the dotted line. You must only pick points that are sitting in the solid line, or integers that are in that unshaded region. I hope that one is clear. Then let's look at the next part. When we are drawing inequality graphs, shading unwanted regions and finding the maximum and the minimum amount. This is what is this? This is where you need now. You draw the inequality, you shade, you find the maximum or the minimum point. For example, it said Zoe buys X lemons and Y oranges. She must buy at least 2 lemons. She must buy more orange than lemons. She must buy a total of at least 8 lemons and oranges. This is now we are just given the word equations, the word problems. Then you have to come up with your own inequalities. Then the first question said, write down the 3 inequalities in X and Y. From your statement here, what inequalities can you write? You can see which one represent X and which one represent Y. If it say she must buy at least 2 lemons, the number of lemons, that is X, should be greater than or equal to 2. That's why the inequality is like that. And then it said she must buy more oranges than lemons. The oranges are represented by Y. The number of lemons, that is Y, should be greater than the number of X. So then Y is greater than X in this case. And then the next statement said she must buy a total of at least 8 lemons and orange. The total, the number of orange and the lemons together must at least be 8. At least means it should be either greater than or equal to 8. That's why our inequality is like that. Then from there, after you have done your inequalities, you have to draw them in your inequality graph. You can see the type of inequality signs that you're having. This is x is equal to 2. You can see you draw your graph like that. X is equal to x, you know the graph that, as I said, you replace these inequality signs with equal if you are to draw the inequality graph. And then x plus y is equal to 8. This is what you have. Use the x-intercept and the y-intercept method to see where your graph will cut the x-axis and where it will cut the y-axis to draw that. And then again, you shade the unwanted region. And then B said, on the graph show the region R that represent the 3 inequalities. You only get that region exposed once you shade your unwanted region. And I want you to practice how to shade unwanted region. Which region is not needed? It just depends on this inequality. If you know the meaning of greater than, less than, then you know which part is not needed, which one is not shaded, or it should be shaded, and which one must not be shaded. Then C said a lemon cost $1 and an orange cost $2. Find the smallest. The smallest, now we are talking about the minimum here. Sometimes it says smallest, greatest. It depends. Is the question asking you to get the minimum, the maximum, or maybe both? So read the questions and so that you know what the question is. So then this is where you use the expression now. Like it say lemon cost $1. That x, 1x must for 1 lemon, plus 2x, 2y for the orange. This is the expression. Then from there you pick points in your Cartesian plane, in your unshaded region. You can see this region is not bounded up there, it's going up. We don't know where it stopped, so we can only use the part that is bounded, that we know this is what we have. And when it comes to, remember that the maximum or minimum values always occur at or near the corners of the required region. If the region was bounded, like maybe if the Cartesian is like this is my region here, this is the unshaded, this is shaded here, this is shaded here. If I to find the minimum and the maximum, I only pick this. I only target the corners of my unshaded region. That is obviously one of the corners will give you the minimum or the maximum. Now, if maybe this line here is dotted line, I cannot pick this point because it's sitting in the dotted line. I cannot pick this point because it's sitting in the dotted line. Therefore, I can pick this point, but I have to look at the points that are closest to this point now. Because I cannot pick this, then you have to pick some other points closer. Then you see, like in this case here, the person cannot pick this point because it's in the dotted line. So you cannot pick this point, you cannot pick this point. So you can pick points that are closest to this point here. The point that are closest is this one, and then the one that is in the corner now of the shaded thing, of the lines, so that you can see which one will give you either the minimum or the maximum. I want you to practice on that so that you cannot make any other mistake. Okay, let's move on. Still on the inequalities. Sometimes the question will ask you to determine the inequalities from the graph. Like in this case, this is even much straightforward because you are even given the equations, you just turn them into inequalities. How do we turn them in the inequalities? You now look at the part that is shaded or the part that is not shaded. Now the question normally we focus on the unshaded part. Like if you look at this line, x is equal to 4. What inequality is presented by this line, provided that this is the unshaded part? So you can see that these numbers below here, they are all less than 4. So then for that inequality, you can say x is less than, and what type of line are we using here? This is a solid line. I mean, not solid, but it's a dotted line. For a dotted line, we can only use this. So you can say this x, these numbers here, we represent by them x by x. We represent by them by x. 3, 2, 1, 0, and so on. These numbers, we can say they are less than 4. They are always, we are using this one because this line is a dotted line. If it was a solid line, then we have to use that. I hope I'm clear on that. How about this? This is y is equal to x. Y is equal to x. Turn that, this equation, into an inequality. What type of numbers are? What relationship can I say about these numbers in the unshaded region? Therefore, when it comes to drawing up the inequalities, make sure that you really know how to give the correct inequalities. Practice makes perfect. Hope you will do the right thing there. Okay, let's move on to the second unit. We have to do with coordinate geometry. Under coordinate geometry, these are the points, or these are the sub-units we have. And it's still quite a number of things, quite a number of rules and so on, and then you need really to know what to do with each. Let's look at the finding the equation of the straight line given 2 points. This part is quite similar to Mathematics 5, where you find the gradient. Finding the gradient is just the same thing, whether it's in this unit or the other unit, module or the other one. So how do we find the straight line from the 2 points? It said find the equation of the line passing through the 2 points 4, 6, and 8 and 12. How do we find the gradient? We have this formula, y2 minus y1 divided by x2 minus x1, or the change in y divided by the change in x. Then you substitute. You just substitute your values. Which one we want to be your first values or the second values, and so on. But if you please, y2 minus y1 over x1 minus x2, this is totally wrong. If you are starting with your first point, start with your first point. If you are starting with your second point, make use of your second. Be consistent. This one I have seen it and it's wrong. Be consistent, please. Don't make that mistake. So it said, first of all, it said find you want finding the equation. To find the equation, we know the equation of the straight line. Y is equal to mx plus c. For us to find the equation, we only need those two numbers, the gradient and the y-intercept. I know how to find the gradient, therefore find the gradient first. Then from there you substitute the gradient into that general formula. Once you know this number, then you can get this number. You just substitute. Now how do we substitute? Take any point and then you substitute it here. For example, here the person took this point and substitute in this general equation. Y is equal to 3x plus c. Since my gradient here I got 3, then I want c. So then you solve for c. Find x and y. This x and y, they are just coordinates here. You substitute them in that general equation and then you find your c. Once you find your c, you know your formula. You'll be able to write down your formula. Okay, what if you are finding the equation of the line parallel to other and the other line? If the lines are parallel, they have the same gradient. So as you can see them there, those lines have the same gradient. If you look at the gradient of this line, it's 1, 2, 3. This is the gradient of this line is 3. So as 1, 2, 3, 1. This one is also 3. 3 units up, 3 units down or to the right. So then the equation is, for this equation, they say the equation for this line is y is equal to 3x plus 6. You can see the gradient is 3 and the y-intercept, the graph cuts the y-intercept at 6. Therefore, the gradient or the equation is y is equal to 3x plus 6. Y for this one, the gradient is 3 and the y-intercept is negative 9. It's going up. I think it will cut somewhere here, which is at no, it will cut down the y-intercept down. If you extend it down there, remember it's just going, it's infinite. It will continue. If you extend it, you see the y-intercept. For according to this, the y-intercept is negative 9. So you can see the gradient is the same because they are parallel. Now, what if the question asks you that? Find the equation of the line parallel to y is equal to 2x plus 1 and passes through the point 5 and 4. So we want to find the equation of this line now. this yellow line. Provided that the equation, this line is parallel to this, find the equation of this. How do we get that equation? We know that the gradient is the same. If the gradients are the same, then we have this general equation, y is equal to mx plus c. That is a general equation for the straight line. Our gradient is 2 because the lines are parallel to each other. Y is equal to 2x plus c. What I need is just the c. To get the c, you substitute. Find x, find y. Now you are given the 2 points here, the coordinate. My y is 4. That will be 2. My x is 5 plus c. Then from there you can see you are just solving for c. 4 is equal to 10 plus c. Therefore, negative 6 is equal to c. The equation is now going to be y is equal to 2x minus 6. Because I know my gradient, I know my y-intercept. That is all you need. We only need these two to write down the equation of the line. Now it said find the equation, number 2 said find the equation of the line parallel to negative 2x plus 4 that crosses the x-axis at negative 3. Now it said it crosses the y-axis. That is even simple. At negative 3. If it crosses the y-axis at negative 3, that means our y-intercept is what? Negative 3. Therefore, that equation is that's going to be y is equal to negative 2x minus 3. Because the gradient is the same. The gradient, if this is negative 2, the gradient of this line is also going to be negative 2. It crosses the y-axis at negative 3, meaning the y-intercept, that is c, is negative 3. That is it for that. What if the equations are, or the lines are perpendicular? Two lines are perpendicular if their products, the gradient is equal to negative 1. The gradients of two perpendicular lines are reciprocals of each other with opposite signs. Now, when it comes to perpendicular lines, if the gradient of one graph is 3, the gradient of the other graph is going to be, it said, the gradient of two perpendicular lines are reciprocals of each other with opposite sign. Remember, 3 can be written as 3 over 1. What is a reciprocal of 3 over 1? Is 1 over 3. This is a positive gradient. 3 over 1 is positive. Therefore, this one will be a negative. If one is 3 over 1, the other one will be negative 1 over 3 if the gradients or if the lines are perpendicular. So then make sure that you know that. You can see that this one, it says this, the gradient of this line is, or the equation of this line is y is equal to 3x minus 1. Y for this one, you can see the perpendicular lines, they cross at right angle, right? So it will be negative 1 over 3x plus 2. The y-intercept can be different. They can cut the graph at different points of the y-axis. But the gradient is the main thing that you have to look at. For parallel lines, the gradients are the same. For perpendicular lines, the gradients are reciprocals with opposite signs of each other. Let's look at this question. Find the equation of this line A. Line A, you can see, line A is this one. We want the gradient of that line, the equation of that line A, provided that this line is negative 4 x plus 10. If one line is negative 4x plus 10, and you are given that the two lines are perpendicular, look at the gradient. If this is negative 4, the other one will be a positive. If this is 4, this is 4 over 1, so then the other one will be 1 over 4. Therefore, the gradient of the other line will be positive, or 1 over 4x, and then plus what? Plus c. Now we need to find our c. For us to find the c, we know the point 7, 2. We can substitute those points. 7 is the x value, so it will be 2 is equal to 1 over 4 times 7 plus c. Then you solve for c. Once you find c, then you get your equation, just like that. The same with this. Determine the equation of the line perpendicular to 2x plus 1. If it's perpendicular, look at the gradient. If it's 2, then the gradient of the other line is going, if this is positive, then if the gradient is 2, then this is going to be negative. Remember, this is 2 over 1. The reciprocal of 2 over 1 is 1 over 2. So the gradient of this other line will be negative 1 over 2. Then find C, substitute x and y in your general equation for you to find the equation. Then let's look at the second unit, which have to do with geometrical terms, facts, and applications. We have quite a number of things. This is where we do the angles, similar shapes, properties of angles in a circle, and so on. Make sure that you go through the units so that you know what is expected from you. Let's look at the circle now. We must know how to get the arc length and sector area of a circle. So then the picture is just showing what we mean. This is the arc. Arc is just a part of the circumference of the circle. You can see the sector area, the area what we mean. You can see the radius, the central angle, major arc, the minor arc, the central angle, because sometimes you say find the major arc or maybe the minor arc. It depends. The major arc, the main sector, the radii or the radii is only one, the minor sector or the minor arc, and so on. So that you show, when you come to the circle, you really need to know the different parts of that so that you'll be able to do the right thing. How do we work out the arc length and the sector area of the circle? We have these two formulas. The arc length is a fraction of the whole circumference. You can see the arc length is a fraction of the whole circumference. So for example, this is the arc. It's a fraction of the whole, x over 360. You know, a circle is a revolution of 360 degrees. So then if you can see that this is x over the whole circumference, which is 360. So then this is the formula times 2 pi r. This is just from the formula for the circumference of the circle. If you can remember how we work out the circumference of the circle, is 2 times pi times the radius, or the pi times the diameter. Okay. The area, the sector area, we use this formula. N represent the angle over 360 times the area. The formula for the area of the circle is pi r squared. So you see that when finding the area of the sector, you are actually finding a fractional part of the area or of the entire circle. The fraction is determined by the ratio of the central angle and so on. So just you look at the angle that's subtended by that sector times our 360 and then times the area of the circle. That is the formula. The second unit, unit 9 in this module, is about trigonometry. Trigonometry is, we have trigonometry in right and non-right angle triangle. This is where you use the theorem of Pythagoras, the formula, the ratios, the sine and the sine function, cosine function, and then calculating the area or the angle between the line and the plane. So then here we are just having a summary of the sine and the cosine functions. Most of you know the SOHCAHTOA, and I'm happy for that. Most of you know how to use the theorem of Pythagoras, but some of you do not know still how to use the sine and the cosine rule. The cosine and the sine rule only work with non-right angle triangles. Now, if you look at this shape, it's a non-right angle triangle. None of the angles is 90 here. Now, so then you can make use of we either use the cosine rule to find the side or maybe to find the angle. So then to find the side, we use this. You can make use of this formula. A squared is equal to this side squared plus this side squared minus 2 times this and last multiplied by the cos of this angle here. So in most cases, for you to find the cosine rule, we have the side and included angle and the side angle side in that row. For us to find the angle, you must have all the 3 sides given and then use this formula. The cos of this angle is equal to that side b squared plus c squared. Any side, you can start with any side divided by the two sides. Which side should we use? If you are finding this angle, you know this angle is opposite this one, so then we use these two angles, or you have to use these two sides here. So then your module is having, it's quite straight on that. It's having nice examples when it comes to the cosine and the sine rule. Go back and see the difference. And the sine rule, for the sine rule, I always say find a full pair and a half pair. At least you must be having a side opposite to a given angle, and one side or the one of the angle is missing. So you can see here, this is the full pair. 10 and 43 degrees are opposite, but 16 and the missing angle, they are also opposite. This is the full pair and this is the half pair. Therefore, you can use the sine rule. And for us to, if you are calculating an angle, then you put the sine of those angles on top. But then you can just use the two sides. And then for this one, if you are finding the side, you can see you are calculating a missing side here. You can see you are still having a full pair. 9 and 55 degrees, you can say it's a full pair. And then 62 degrees and this missing thing, it's a half pair, because one of the sides is not, the opposite side is not given. Therefore, use this formula for when you are calculating the side when you come to the sine rule. For the cosine rule, angle, side, angle. Sine rule, full pair and the half pair. Then, so then you can see what is given here. When do we use this? For the cosine rule, we need two sides and an included angle. So then that is what you need. And then if you want to find an angle, you must give, or you should get, at least you must be given all the sides. For the sine rule, at least for you to find the side, you need two angles and any side. And then you can see here, to find the side, you need two angles and any side. And then to find an angle, you need two sides and not an included angle. You need two sides and not that angle should not be between the two given sides. So then make sure that you go through to the sine and the cosine rule. Okay, these are the examples of the sine and the cosine rule. I want you to take time and to go through, so you can see when we are talking about A and B and C, what is that we mean. So if this is angle A, the side opposite A is A. We use capital letters for the angles and we use the small letters for the angles. So A straight to with A, C with C, B with C. So then you can say this is the pair of C, this is the pair of A, or this is the pair of B. And you can see how to use that. So this is the sine rule and this is the cosine rule. Look at that, study these two examples with time, see how they are being worked out. And then if you have any question, please do not hesitate to contact me. The next unit is statistics. This is where we work out the mean, the median, the cumulative frequencies, and so on. So under this chapter, I just want us to look at the estimate mean of grouped and continuous data. This is one of the questions that 4 or 3 marks in the examination, but most of you still don't know how to do it. So for us to find the mean of the group data, this is what the formula we have to use. We have to take the sum of the interval, take the interval times the frequency, and then you multiply with the sum of the frequency. I have the example here. Now I want to find the mean of this grouped. You can see this is grouped data. So for us to find the mean, in most cases you are just given this part. You are only given the class intervals and the frequencies. The midpoint and this part you are not given. So then we always add those 2 extra tables for us to find the estimate. The question always says the estimate, because the answer is just an estimated, because these values, they are just grouped. We don't know whether they are 144, 140 to 150. We don't know whether it's 144, 143, 150, 149. We don't know, but it's just in that range. That's why it's just estimated mean. We find the midpoint. How do we get the midpoint? we'll add these numbers together, like 140 plus 150 divided by 2, you get 145. 150 plus 160 divided by 2, 150. 160 plus 170 divided by 2. These are the midpoints. Then you take these midpoints, then you multiply it with the frequency that is given. You can see it gives us this. Now to find the mean, this is what we add together. The sum of this divided by the sum of the frequency. You can see this symbol means sum. The sum of f and x. F represents the frequency, x represents the midpoint, and then divided by the sum of f, the sum of the frequencies. If you add the frequencies together, it gives us this. If you take the midpoint times the frequency, give us this. So then 8,250 divided by 51 will give us the estimate mean of this question. The next one is probability. I want you to really look at this, especially drawing probability tree diagrams if they are there, and then just how to work out the different probabilities. Under this chapter, I want us to look at the cumulative frequency table and the curve, which is called the archive of the frequency. Most of you do not know how to work out this, but when it comes to the cumulatives, the word cumulative, a cumulative frequency graph allows us to measure the spread of data by finding the value at each quarter or each quarter of the data. We can find the median and the median, the interquartile range. These things here, these are the things that we normally look at when it comes to the frequency curve. Like we have to find, you must know how to work out the upper quarter. Upper quarter we use 3/4. Median is 50% or half of the values, and the lower quarter we use 1/4 of the values. Interquartile range, we minus upper quartile minus the lower quarter. You can see the difference between the highest quarter and the lowest quarter. That is the interquartile range. Now, this is what you are given. Imagine you are given this table. Now, it said we'll find or draw the frequency curve. We use the cumulative frequencies. Like you add frequencies together. The first one, 5 times plus 9 is 14. 14 plus 13, 27. 27 plus 10, 37. 37 plus 3, 40. Like that. That is how we get the cumulatives. And then when you are drawing the frequency or curve, then cumulative frequency curve, the cumulative frequency, you can see the word cumulative frequency is always placed on the y-axis, and then the score, what is that you are measuring, is placed on the x-axis. Now when you are placing your data, you always use the last point. We always use this last number. 20 goes with 10, 5. 20 with 5. If the score is 20, the cumulative frequency is 5. Then you plot there. And then 30 with 14. Remember, we use cumulative frequencies. We don't use this number when we are drawing. We use the cumulative frequency, but we only use this last number of each interval. We use the last numbers. Then from there, you draw your nice curve. If the question said find the lower quarter is either 25% or 1/5 or 1/4. Like lower quarter, we use we say it is Q1 for lower quarter. It's 1/4 times 40. 1/4 times 40. Then the answer that you get, you go down. Like what is 1/4 times 40? You get it's 10. You get 10. From there you can see here 10 is not your final answer. You come back to your graph, you read at 10 and then read from your graph what answer is there. So you can see your lower quarter here, it's 26, just like that. If it say find the median is the middle term. If the numbers are up to 40, the middle is 20. 20, then you go read your answer. Upper quarter, 75% or 3/4, I mean. You get your answer, come here, and then you read your answer. It should be like that. Okay. The last question unit is transformation and vectors. I hope when it comes to transformation, this is I'm just having the summary of the different transformations that we have in our mathematics. Translation, you must know how to describe. In translation, we use vectors. The first number is always the x. You either go right or left. And then the next number is always the y. You know why it's either up or down. So depending on what. So you can see that this diagram was translated by using the vector 3, 4. The person moved it 3 units to the right and 4 units up. If you look at that, this square, 1, 2, 3 and 1, 2, 3, 4. You see that is how the translation works. Rotation, you rotate. To describe a rotation, you need the angle, the direction, the coordinates of the center. How was the shape rotated? Okay, how was the shape rotated? Is it 90 degree, 180 degrees, 270 degrees? That is the angle. Direction, was it clockwise or anti-clockwise? And the center, where is the center of that rotation? What was that? You can see if you are rotating it anti-clockwise, you go left, clockwise, just the way the clock moves, that is clockwise. So you can see that they say that this shape was rotated 90 degrees clockwise about center 2 and -1. So then for you to get those three, mostly 3 marks when you are rotating. And you must also know how to rotate the shape. If you say rotate the shape, you must know. We have a refraction. Under refraction, we describe by naming the line of symmetry. Refraction is it's a flip. There is always the distance, the same distance between the two shapes, the object and the image. So we can say that this refraction was done in the line x is equal to 2. Then we have enlargement. Enlargement, I find it quite a challenge to most of you when it comes to drawing enlargement, but I want you to practice on that. Enlargement, when it comes to enlargement, to describe the enlargement, you need the scale factor, the coordinates, as well as the coordinates of the center. Like, how do we get the center? How do we get the center of enlargement? We join the corresponding corners of the shape with the image. This corner is the same as that, you join them. This corner corresponds to this, you join them. This corner corresponds to this, you join them. Wherever they are going to meet, that is where the center. Then you just give the coordinate of that center. And how do we get the scale factor? So we can say this is enlargement, scale factor of 3. How do we get the scale factor? You just divide the corresponding side. This side corresponds with this side. How many units here? 1, 2, 3, 4, 5, 6. 1, 2. 6 divided by 2, it will give us 3. Or maybe here, this side, it's always good to use the vertical or horizontal distances, because they are easier to count. And this one is 1, 2, 3, and 1. 3 here and 1 here. 3 divided by 1, it will give us 3. The scale factor is 3, and you can see the center of enlargement. So we can say that this enlargement was enlarged by using the scale factor of -2. It depends on which one is the image and which one is the object. Under enlargement, the bigger object is not always the image. Sometimes an image can be reduced, especially if the scale factor is a negative number, then your image will be smaller than the object. That's why, like this was the image. Yes, this is the image. Therefore, the scale factor is a negative number. Again, I want you to go through and see how we play with enlargement. That comes to the end of our mathematics 6. I want you to really study very hard. Go through your assignments as you are preparing for your examination. Do not hesitate to contact me. That is my contact number, 081-2009-524, or you can just give me your email. And it's when it comes to the questions, most of you are having WhatsApp. You can just WhatsApp the question to me. I don't understand this, then I'll find time to explain it to you. All the best for your study. Stay safe.